Alright guys, let's get into it. So the way I'm going to do this video key is about a page at a time. So I'm going to break it up as much as I can and what makes sense. So you can kind of just make sure you're tuning into the parts that you really want to see or maybe need. Or if you're going to watch the whole thing so you get regular breaks, because this is going to be quite long. So hey, let's get into it. So here's page one, objective one, or at least topic one. The construction of geometry, looking at points, lines, and planes, and just kind of all the ways they can get into it. All right, so for question A, identify each of the following constructors by name and by proper notation. So make sure you're doing this part. That's really the important part here. Simply identifying what it is isn't a terribly difficult task, but the notation is the part that I'm really going to tune into on the test. Anyway, so let's go to it. So here we have these 2 points A, B, and let's say we have all the points collinear to A, B, but it doesn't extend past A and B, so this is definitely going to be a line segment or just segment. And then the way we name segments are by the endpoints and then drawing a small segment sign above it. So here we have segment AB. Moving right along, we see 3 points are located on the plane. So remember, 3 points do dictate where a plane is located. So in this case, we can call this a plane. And the proper way to note a plane is by picking 3 points out of the plane and putting them together. So that's not 3 points. Together in this configuration, it refers to a plane. Point by itself, so this point, I would call that point Q. Here we have something starting at M going through T, all the points collinear in a single direction. We call this guy a ray. The way we name a ray is by the 2 points starting at M, passing over T, so ray and T. Here we have all the points collinear to 2 points, including the ones past those 2 points. So here we have a line. So the way we name a line is by looking at the 2 points, really any 2 points on that line, drawing a small line symbol above it. And that's all for that row. So just some quick proper notation. Some other notation that you might want to be kind of aware of would be something like for a distance. Like if I just give you like 2 points, column M and C, and just those 2 points, and maybe I'm referring to kind of like the space in between. Remember, that's distance, and in this case, it would be distance MC. Okay? So just next one, just in case you might want to know for the test. If you're an 8A student, this question was a little bit of a mess. So I went back and revised it and republished it. So if you go to the Google Drive now, or you go to like my homework, whatever, this is going to be the new version of this question. But if you picked out like the inaccuracies of the first version, good for you. Like that's some really good work. But here's how it currently sits. Now I'm going to put all this into a single diagram. So it's important that we kind of read the entire question first, and then we kind of make a decision about what it looks like. So I'm going to try to highlight some of the important pieces here. So number one says, if I have line AB and line segment CD, they should be perpendicular, and also the CD should be a bisector of AB. Now this term bisector just means cut in half. And now I'm going to warn you, there's lots of different ways to do this. I'm just going to do the version that comes most naturally. So I'm going to pick 2 points, AB. It should be a line, so I'll extend them and then arrows. So that's a line going through AB. I should have the second line, which I'll make in orange. Now that's a line segment CD, and CD should be a bisector of AB. So I'm going to put C down here. I'll put D above it, and line segment CD. Now again, there's lots of different ways you can do it. This is just kind of the way I'm choosing. So please take note of that. So CD also has to be a bisector of AB and be perpendicular. So we can put in some symbols to make sure that's going to be kind of interpreted that way. So here you have the perpendicular sign, meaning that it's going to be crossing at a right angle. And then from A to this point where it crosses should be the same as from the point where the cross is to B. And so we'll use tick marks to note that. So that will ensure as the reader that they're looking at a bisector, right? Next piece, let's go to pink. So F is collinear with A, and they are not together collinear with C. So what this means is I got to pick an F that's in the same line as A, but it should not be with A in a line with C. So like in other words, I couldn't pick it like here, like that would be no good. But this still gives me lots of options. I'm going to put it right here, right above A. So remember, we could form a line between those 2 points, even though like you can't see it, quote unquote. It's totally there. If I wanted to fill in all those collinear points, I could. So moving on, G is collinear with B, but they are not together. But they're together non-collinear with C. So same kind of deal. I got to make it so it's in line with B, but not with C together. And also, you have this condition here. that the ray FG should be parallel to AB. That's what these two lines mean, parallel. So we're going to make a ray going for F to G and make it parallel with original AB. So again, lots of different versions of the diagram, but that's the one I'm going to go with for now. If yours looks slightly different, just note like the key features, like the structures of like ray, line, or line segment, and what should be parallel and perpendicular. So sketch a single diagram that incorporates all the following. Number one, we have ABC exists, which means we just have like this plane. So I'm just going to draw like a nice big plane here. I'm not going to pay too much careful attention to kind of like how it's shaped, because remember, we're just noting a flat surface. Now we do have ABC, so I'm going to go ahead and mark ABC on my plane. DB is non-coplanar with ABC, so I do have to create a line segment DB. B is one of the points on my plane, and so that means I do have to pick a D, and so it's non-coplanar, which means it just can't lay on the flat surface. So I'm going to draw it actually directly above it. I'll call it D is my line segment. So it's kind of sticking up from like the surface, like so you can imagine like a pencil standing straight up off your desk. Like that's what D should look like in this case. And again, more than one way to interpret that, but that's just the way I am. So now we have to pick an F so that AF and AC, AF is perpendicular with the line AC, which means I got to draw that in, and AF is coplanar with ABC. Okay, well this is going to be tough. So first let's pick the F really carefully. So F has got to be coplanar with ABC, which means it's got to be on the plane. So I think it's going to belong here. Oops, get out of here, magnifying thing. So I think it's going to be, I'm going to pick it right here. So that's going to be on the plane itself. And I got to make AF, so a ray that goes through A and F. And so it's perpendicular with AC, and AC is in line. So I'll make that a line. And then perpendicular means it should cross at a right angle. So this is kind of like on the flat surface. Like if this was your desk, it would be laying flat on the top of the desk. So you'd have two right angles, or you have a right angle here, then you have a line sticking straight up. I know it gets a little tricky to see because it's actually, it's basically a three-dimensional drawing that I'm kind of doing in 2 dimensions, but I'm trying to give you the best visual I can. Again, more than one way to do that, but that's the version I'm throwing out there now. All right, so to finish up this page, we have this diagram at right, and we just want to pick out some possibilities. And so for these, I should warn you, there could be more than one answer here. I'm going to provide as many as I can, but I probably won't exhaust the whole list. So I have a set of 3 points that are non-coplanar. Well, I'm sorry, that are coplanar. Well, lucky for us, as long as these points exist, they're part of a plane. And so you can literally pick out any 3 points. Like it doesn't matter which, you can literally pick out any 3 points. And this has everything to do with the fact that any 3 points can form a plane. So like, let me show you what I mean. So let's say I picked R, I picked A, and I picked O. There exists a plane that goes through all 3. It's kind of going to be sticking up against the wall, the green wall, so to speak. But again, pick any 3 points. Have a Q, let's go with N, and let's go down here to S. So again, you have a plane here as well, because again, any 3 points will do it. T, P, O, or U, excuse me. There's another plane. A, S, O, here's one right there, another plane. So there's this kind of standing rule that any 3 points will be part of a plane. So literally any 3 points will work. So pick 3 and you are good. Now the important part here is not getting the question right, but understanding that because any 3 points can form a plane, that you can pick any 3, right? So a set of 4 points that are non-coplanar. Well, this one actually has almost as many answers. Basically, you just can't pick 4 points that exist on the same surface. So I can pick like M, N, O. So as long as I don't pick A or P, I actually have a 4th one, which altogether be non-coplanar. So if I pick like M, N, O, and then added R, like that would be a non-coplanar set because they couldn't exist all on the same surface. So I'd have these 3 on the same surface, but to include R, I'd have to add like more surfaces, and then that would not make it coplanar. That'd actually make it not coplanar. So really, any 4 points, as long as any of the 4 points do not lie on the same plane, okay? Which I know is kind of what the question states, but hopefully with the explanation it makes a little more sense. So I can't pick 4 points that are pink or 4 points that are green. I just have to pick like 4 points, period. So really, the answer to this question would be any 4 points Okay, so not all on green or pink. Okay, so pick any points that belong to both identified planes. And I want you to limit this kind of discussion to just the identified plane. So really, just A is the one I'm looking for. That simultaneously lays on the horizontal pink plane and also this tilted green one. None of the other ones really do that. Like you could argue that you can kind of incorporate them in some way, but really A is the one that does it naturally. So let's just go ahead and write down A. So instead of 3 points that are non-coplanar, wait a minute, hold up. 3 points are non-coplanar. Wait, didn't we just say like in this one that any 3 points would totally work? I think that is a trick question. Okay, so there is no answer to this. This is a trick or a trap. Okay, any 3 points actually are coplanar, and I can't prevent that from happening. Like if I just pick 1, 2, 3, that's automatically gonna be a plane I can define between them. So any 3 points will be coplanar. That is a trick question. So let's move on to the next one. Pick a set of 2 points that are non-collinear. Whoa, wait a minute. If I just pick out 2 points, like T and P, like there I can totally draw a line between them. Well, maybe I messed up. How about U and O? Well, it's a line that exists between them. N and Q? No, it's a line. N and R? No, it's a line. I think that's also a trick question. Hey, wait a minute. Two trick questions in a row. That's so unlike Mr. Collins. So these two questions are important. Not so much because I was trying to trick you, but if you actually found an answer them, you're kind of missing a concept here. It's totally true that any 3 points would be non-coplanar. That's true all the time, no matter what. In the same way, if you just pick 2 points, that's totally gonna be non-collinear. True all the time, no matter what. So why they're trick questions? Because they're impossible to answer. Like those are the exact situations that create not that create coplanarity in a set of any 3 points, or collinearity in a set of just 2 points. So that's the end of page one, so to speak. So there'll be more videos to follow, obviously. But that is the basics of the beginning of geometry. So you can definitely expect that to be kind of fair game on the test. So that's the end of part one. I'll see you guys in part two.